it's working great. Hey guys, we're getting started. Damir, please take a seat. And a few photos. So welcome everyone. Thank you for joining this event. It's a big pleasure to have you here. I'm Sébastien Forestier, so the head of the Massa Foundation. Now we have two entities. Damir is head of Massa Labs, and I'm on the foundation side. This is the first Massa Breakfast. I hope you enjoyed the breakfast. But now we are going to have a few presentations. But first, I would like to thank Blueyard and Jouanny in particular for hosting us today and for also advising and supporting us since we started Massa. So what's Massa for those who don't know? It's the first truly decentralized blockchain with high performance and with a few unique technical breakthroughs that we will present, like autonomous smart contracts. So today we have 4 presentations from the team and also from ecosystem projects. Leo and Mohamed, I don't know where he is. I will present the roadmap. Leo will present Dusa, it's a decentralized exchange on Massa. Mohamed will present Cameleonz, and Damir will tell you more about autonomous smart contracts. So about the roadmap, I divided this presentation in 2 parts, the recent milestones, so the past, and the next steps, so the future. In the recent achievements, the most important milestone was, of course, the launch of the mainnet on January 15 this year, after 2 years of testnet. During testnet, we reached 5,000 transactions per second with 8,000 nodes. So this was already the most decentralized and scaled network. And that's thanks to our parallel block technology. You can see a glimpse of the block structure here, but we can give you more details in the chat afterwards if you want. So the launch was smooth. After 6 months of mainnet, we processed, I think, 1 billion transactions. Not all of them are super useful transactions, but it just shows the power of and the scale of the blockchain. The autonomous smart contracts are live since January, and they are being used by a few projects already. You will see a lot with Damir. Here you can see the main Explorer and 2 wallets. Massa Station, it's the official wallet. Berbai is a community wallet made by someone in the community, very talented. What happened next? We did a community sale, public sale on Republic. We raised 3 million. And then in February, we started a partnership with Starknet. Damir can tell you more about it also. And we started our grant program. So that's on the Massa Foundation side. If any builder, developer want to do something on Massa, they can just come talk to me or use the website. There's a form, and we can help. We can help with funding. We can help with support on any other topic like marketing, co-marketing, etc. I'll give you, by the way, a few statistics on it a bit later. We also started the bounty program. So this one is working the other way around. We say what we need, and some builders just take the bounty, like do the job, send us the GitHub link, and we check and we give the bounty. Also in March, we distributed the first public sale tokens. And in April, we did the second public sale on the Maker just before launching the token. So that's the second most important milestone, I think. On April 15, we listed Massa on exchanges, 2 centralized exchanges, Bitget and Mexi, and 1 decentralized exchange, Dusa. At the same time, we launched the Massa Bridge, for people to bring liquidity easily from Ethereum for now. And also we started, so it's still going on, a liquidity incentive program on Dusa. So if you're using Dusa, the best user, the one who provides the most liquidity in the best bins, let's say, will get the most rewards. Since then, other ecosystem projects have deployed on mainnet, but here I'll mention only a few of them. This is the first NFT marketplace, Perfect Universe, with the first NFT series, the Charlie collection. By the way, Perfect Universe is using autonomous smart contracts to manage the auctions. And they also did the first meme coin. It's called Pur. And yeah, just check it out if you want. A few weeks ago, we also deployed the Massa name system. That's the first step towards on-chain web, a big feature we want to deploy in the coming month. And this is a way to book domain names like anything you like, .massa. And this will be used later if you want to upload front ends of the apps on-chain. But for now, you can use it as an alias, a bit similar to ENS. For instance, if I want to send a token to Damir, I can, in Massa Station, it's already integrated. I can write the Massa address, test Damir. This was the first booked address. And Massa Station translated, resolve it directly to the good address, which is in the DNS. So the DNS is on-chain and is fully decentralized. The smart contract is live since June 24th. We have already 7,000 names on it, so don't wait if you want to take your first name or whatever. Many are free still. Yes, here I show some statistics on the grants. So this is only on the Massa Foundation side since February. There were other grants before on Massa Lab side. On my side, we got 51 applications, granted 13. There are 35 milestones in total, so each project can have a few milestones along the development. And that's for a total of 1.5 million Massa that are vested and that we will give only if the milestones are reached, of course. Regarding the topics, we have quite a lot around the tooling, so to help people build on Massa or to provide any sort of tools or help for builders or for users. A few in the NFT space, in DeFi, around the community, so to help awareness basically around Massa, education, and one real world. I can't tell you already, but you will see later when we can. Same for the bounties. We suggested 9 bounties. This is mostly technical and around the tools. So, yeah, anyway. Cameleonz is one of these granted projects, but I don't want to spoil what's going to happen, what's happening right now and what's going to happen in the next weeks. So that's probably the first next step. Then what's going to happen in August is that we will deploy the Massa Community Forum. This is a place where we want to have conversations a bit more constructive and sometimes more complex conversations about the future of Massa, in particular around governance. It would be inspired by its research or Bitcoin Talk, if you know them. We will deploy it soon in August, I think. A bit later this year, we'll deploy the full on-chain feature, on-chain web. So what's missing right now is a way to upload and to access the websites that we would put on-chain. we have the DNS, on-chain DNS, since a few weeks. We have the backend for the apps, of course, that's the smart contracts. And we are missing a way to put the front ends, like whatever, HTML, JavaScript, CSS, whatever you want on-chain, so that users can retrieve the full DApp, actually, from the blockchain with no intermediaries, with no hacks, with no censorship. Another topic we are working on is another version, let's say, of autonomous smart contracts, or another way to book the space, computational space on chain with guaranteed execution. Same, I won't spoil Damir's presentation. And okay, now to increase awareness of these blockchain features and of the ecosystem projects, we are preparing a community campaign similar to the one we did last September, if some of you remember. That was on the BuildNet, where we reward the most active users of all the apps and of the blockchain in a kind of a fun contest. We will airdrop a few Massa tokens, but also the tokens from the ecosystem. On the technical side, for now, Massa has a WASM virtual machine, and we write contracts in TypeScript or assembly script. TypeScript is very accessible. Basically, any web developer knows TypeScript, so that's very good for accessibility. But still, there are some developers who really just want to copy-paste their Solidity contracts, because also usually they are audited. They don't want to translate and do another audit. And that's why we are going to explore EVM compatibility. I don't make any promise here, but we'll explore it. If it makes sense in the roadmap to develop it, if it's just feasible and not too long, we will just do it. And yeah, finally, another big milestone is that we want to decentralize basically the governance of the Massa protocol, the Massa blockchain, to do that as much as possible. And for this, we are going to implement on-chain proposals. People will be able to propose changes, and people or other people will be able to vote on them. This can be on the blockchain parameters. This can be on the new future features, or this can be around the funding for the grants. So we'll work on this at the end of the year and develop and deploy it probably at the beginning of the next year. Thank you. That's all on my side. I leave the floor to Leo, and I think we can chat if you have questions just afterwards in the networking time slot. Thank you.
Thank you, Sébastien. Okay, cool. Hi, everyone. So yeah, like Sébastien said, I'm gonna show you how we are applying autonomous smart contract and their strengths to DeFi. So the idea is that we're gonna show you the power of decentralized automation in DeFi. So a quick recap about the different subjects we're gonna see today. Firstly, we're gonna see the current DeFi automation issues that the ecosystem is facing. After that, we're gonna talk about our on-chain automation and how we aim to give that to the users in a customizable way, so we can touch as well the users as the builders also to build on top of Dusa. So the idea is that when we started Dusa almost 2 years ago now, we did several hackathons, so we are going behind the curtain on several protocols, and we saw that the number of external dependency on those protocols were enormous. At the moment, most DeFi protocols have some external dependency in some parts and some features, And we're thinking that creates an issue for the future. Because at the moment, we are building the primitive of the next step for the financial ecosystem. And the idea is that if on the base layer, on the primitive layer, we already have some external dependency, it could create some severe issues in the near future. That's why we really loved what Dan Elitzer said almost a year ago from now, that to be qualified as a primitive, a protocol needs to have zero external dependency. And that's why when we check at DeFi, how DeFi is currently being automated, we have two main categories of error. One that is the result of the centralization of this automation process, and the other one that is because so few possibilities are available to automate DeFi, it costs a lot to the protocols. And that's why the first two parts are hacks and human errors that are the direct result of the centralization of servers that help builders and even users automate their strategy or have their trading order being executed in time. And the other part is the cost, because the current solutions available are really costful. For example, Damir was telling me a few weeks back that one of the principal budget of Aave is directly from some automation on Gelato. And now we're going to see how we are applying the innovation of Massa, the autonomous smart contract, directly into DeFi. So just quick recap about the difference between autonomous smart contract and classical smart contract. The main idea is that classical smart contract needs to be triggered to execute the solution for what they are available. And on the other end, autonomous smart contract can wake up by themselves depending on some times parameters and some events parameters. And we are directly applying it to DeFi because if we take the example of a limit order, every piece that you are seeing in green is directly executed on the blockchain, and the part in red are depending of an off-chain part. And the idea is that you're seeing here that the off-chain part is clearly at the middle of the execution, and that could create some risk to the end result. So the idea is that when you place a limit order, you are placing the order, you are checking at what price you want to buy Bitcoin, for example. So let's say you want to buy Bitcoin at 50K. The idea is that you are placing the order stay on chain, but for the smart contract to execute your order, it will need to be triggered by an oracle that will need to check the price and say the smart contract that it needs to be executed. The difference with our application of autonomous smart contract is that when you place the order, you know that the autonomous smart contract will execute it when he sees that the price has reached 50K on-chain. The idea is that autonomous smart contracts are checking the on-chain event every half a second. So when he sees a changement in the state inside the liquidity pools, so when he sees that Bitcoin is at 50K on the liquidity pools, he will directly execute it. But the idea is that limit order is like the most obvious point to develop it, but we can do it for every latent trading order. At the moment, the main part of the volume on AMM is done by swaps, but the idea in finance is that you can do an enormous range of order. For example, we have already also developed the dollar cost average order that help a lot the beginner and even the DeFi expert to build their advanced trading strategy, but we can also deploy it with OCO, trailing stop, and other order on which we are researching at the moment. And the idea is that, like I said, we do not want to target only the users, but also the builders, because we think that giving them those primitives give them the ability to build cool application on top of us, while being sure that they do not have to trust any other third party. Because they only need to check our code, they only need to check our autonomous smart contract to be sure that those features only rely on chain. And that's why we've also adapted not only to trading, but also to liquidity management. Just a quick recap about the current IMM space. IMM at the moment are mainly based around concentrated liquidity. So the UniV3 model, the idea of UniV3 model is that you have liquidity that is shaped inside a range around the active price. And the idea is that liquidity provider need to replace their liquidity each few minutes, for example, to be sure that they are generated fees and to be sure that the traders that are trading on those IMM are getting the maximum liquidity as possible to get the best price. But that creates some issues. The first problem is that retail users are not really apporting liquidity anymore into DEXs because it's too complicated, too much time consuming. So one of the possibilities for them to have their liquidity managed is to give their liquidity to a liquidity manager. But again, when you're using DeFi, you do not want to create some trust at some point, so that clearly creates some issues for them. So that's why when we started autonomous liquidity, we give them the offer to have their position rebalanced due to certain strategy that was predefined. So that gives them a better user experience and a better security because we do not have any off-chain dependency. Of course, you still have the smart contract risk, but like any other protocol. At least we are giving their risk only on-chain, so that gives them a better security, and then they can be sure that their funds is only dependent of some smart contract that they can check on. But that was not enough. We wanted to give them the possibility to customizable those strategy. So the idea is that we have deployed on our beta the possibility to custom two simple parameters. One parameter which is the time. So how much do you want your position to be rebalanced each day, for example? So here you have an example with 30 minutes, an hour, or even 6 hours. And also the size of the range on which you want to provide liquidity on, because that have a serious impact on the profitability that you want, but also on the risk that you want to adapt. And that's where we think it's really interesting, because we could see a future where a user can directly create their own liquidity management strategy with a lot of factors depending on on-chain activities. So all the event, all the market condition, and also time parameters and all the other parameters that could help them mitigate their risk depending on what they want. And the idea is that those all those things with the customizability of the orders of the liquidity management pave the way for a new range of innovation for the users and the builders too. Because for the first time, they know that they can build complex trading strategy, complex trading application on top of really cool primitive that are offering for the first time something that is fully on-chain, so they do not have to add any trust from the base layer for their application. And in terms of the users, they know that they are able for the first time to create their own liquidity strategy without trusting any off-chain server, without trusting any off-chain third party. The idea globally is that we aim to offer the same user experience as a centralized exchange, because we think that centralized exchange are not viable on the future side. And at the same time, while staying always with their phone only on the chain without any off-chain dependency. And that's thanks to this incredible team that we are building Dusa since 2 years from now. You can already test all the autonomous features on our beta. The idea is that the first part of this autonomous feature will be live in Q3 and Q4. And we are already live on mainnet with the core part of the protocol. Do not hesitate to drop us some question and to follow us on our socials. I think I let the stage to Damir now, or Cameleonz.
Hello, everyone. So pleased to be meeting you in person today. And I will be presenting Cameleonz Marketplace that we launched yesterday. And let's start with some good news. We sold out within the first 2 hours. And my name is Mohamed, and I'm founder or co-founder of Cameleonz NFT Marketplace that will leverage the power of Massa's EthCC to reshape the NFT realm. And the idea started from the understanding of the NFT space. We witnessed that it's being a bit boring and status quo. And with the power of autonomous smart contracts, we are launching a marketplace that will allow NFTs to evolve, and we will be supporting community projects. The marketplace will be launched on August, but already you can get your first NFTs. There will be so this is the art. We will have 1,050 items. Why Massa? Because we believe that ESC can be a changing the paradigm of the Web3 industry and NFT space in particular. The vision is to start with art project, but for sure pushing more to attract real use cases that will leverage ESC, and like we can envision to see educational projects like resumes that evolves and many other use cases that leverage the power of this technology. So how will the NFTs evolve? So the idea is to be co-writing the lore within the community. The first evolution will happen next month when the marketplace will be launched. And every month we will have a community event where first we airdrop 20% of the transaction fees to the community and Cameleon holders, and then involve the community to decide for the evolution that is gonna happen. So it's a whole story that is gonna be co-written with the community and NFT holders. Again, this is the piece of art that we started selling yesterday. And Cameleon is a proof of concept for the power of ESC and what we can leverage within this technology. The community, today we gathered a community of around 350 active members, and we intend to call for other projects and builders to be a part of this project. So join Cameleonz if you haven't done that yet, and be part of this new journey. Thanks.
We have some time for questions.
I have a question. So the Cameleon NFT itself will also be an NFT that evolves over time.
Exactly.
Exactly.
And the idea is to create the marketplace and the NFT collection. So the NFT evolves on itself within the marketplace, of course, and it evolves in a breeding game where an NFT holder can interconnect with other NFT collections, and that's the story like we envision to be creating families within of Cameleons within the ecosystem.
The Cameleons are breeding by themselves autonomously.
Yeah. Yeah, like we wanted to start with an egg, so like the airdrop that's gonna happen in 2 weeks. People, like holders, will receive an egg that evolves into a chameleon, and from that chameleon we recreate history back from dinosaurs and to the world that we want to see.
For the NFT marketplace, as a user, how would I be able to utilize this technology using your NFT marketplace?
That's the best question I was expecting, and the whole idea is to facilitate, like make the user experience like the most easy, because not everyone is a coder, and we need adoption to come from artists and users. And exactly, so as a user or you want to launch your NFT collection, you will specify the steps of evolution that you want to see, and they won't be like. You could modify, of course, when you integrate triggers, following a vote within the community or following off-chain data, and you will have steps that you can specify how your collection will evolve.
And can I take, for example, real-life events triggering smart contract without using an oracle?
Definitely. No, you will need an oracle, of course.
Yeah, without me having to code and connect.
Of course, like you can envision like a chameleon that is connected to the Bitcoin price, for example. Like if it's increasing, it would be a happy chameleon. If it would be decreasing, or to the weather forecast in a city. If it's raining, then the chameleon will have an umbrella, and if it's a shiny day, we'll have sunglasses, and like it's a bunch of creativity, and that's why we believe that Cameleon has the potential to be a reference in the whole NFT space, as no other marketplace was dedicated to evolvable NFTs. And like truly we believe that within the next few months, people will watch Cameleon marketplace, how things will evolve, and like the two use cases that I just noticed, to the weather forecast or Bitcoin halving and stuff like that, are like few of the many ideas that we can have, and we are calling all the community to bring creativity and to create collections that leverage the power of AAC. Thanks, everyone. We'll give the hand to Damir, and looking forward to see you.
Thank you. Also, I wanted to quickly mention, speaking of oracles, we just signed a partnership with Umbrella Oracles. They are currently under technical review, and as soon as it's ready, it's going to be deployed. So good news for the oracle space as well. Okay. Okay, thank you. So this one is going to be a bit more technical. So sorry for those who don't like technical stuff, but it's going to be a bit more technical. The idea here is to explain to you how autonomous smart contracts work in Massa, how we made them evolve by themselves on Massa. How is it possible? And why nobody else has figured it out. So first, a quick intro on how a typical blockchain works. In a typical blockchain, you have this workflow. You have a user that's at the bottom here. No, it's not really working, but you have a user at the bottom there that detains a secret key, signs the transaction, emits the transaction, which propagates in the network, and then one of these unexecuted transactions is picked up by a block producer. The block producer adds it to a block. The block is chained to previous blocks, and the blocks are executed in the order of the chain. So whenever a block is executed, the transactions it contains are executed, and the transactions themselves can call smart contracts, and a smart contract can call another smart contract through something called composition. So this is a typical paradigm that blockchains follow usually. But here you see we have a first limiting factor, is that if the user doesn't do anything, the smart contracts are just sitting there waiting, doing nothing. And wait, okay. So if you look closely at what a transaction looks like, a typical transaction, it contains 4 main elements. It contains a tip, a small amount of tokens that is given to the block producer that includes the transaction to basically to motivate the block producer to include the transaction. It contains some validity conditions, so for example, expiration dates or nonces or whatever. Gas limits that give an idea of how much computing power will be required to execute this transaction. And of course, a payload that contains whatever the transaction wants to do, transfer coins, call a smart contract, whatever. So this is a typical transaction. Now, we see that there is an issue. So what happens when there is no user inside the equation? What happens whenever we want to do something without a user signing and emitting a transaction? For example, when we want to detect and liquidate under-collateralized positions that the user already has, so user is not there, but we want to detect that their position was under-collateralized, so we need to slash it. That's something that raises a question. If we want to update a game state without having to require user interaction, so for example, animate some NPCs without the user being there, run on an autonomous AI, for example, if you want an AI to be autonomous and be able to function on a blockchain, same. We need to think how we do that. How can we make NFTs evolve? You got a spoiler on this one, but that's another one. And something as simple as, how do I program a blockchain to send tokens to someone on a regular basis? All this is currently impossible with a fully on-chain scheme. That's why the simplest you can do nowadays is host a server that's called a keeper bot. This server contains a secret key, and this server sends regularly a transaction to the blockchain to automate something whenever, on a regular basis, or whenever it's needed. So that approach obviously has some issues. because, for example, the server contains the secret key. If the secret key is leaked, obviously anybody can start sending these transactions, which is an issue. Same if the server is down, everything stops. Well, you can imagine the issues. So that's why people prefer to delegate this to trusted third parties. So we have a huge market for chain link automation and gelato. Actually, most of the Web3 projects you can imagine, almost all of them use one of these two. They will not advertise it, but they almost all rely on it in the backend to automate their smart contracts. So whenever you don't rely on the user interaction, you need something to simulate a user, and usually you delegate to these two entities. And this raises some problems. First of all, centralization, because you end up trusting these entities with your keys in a way. You end up having to rely on them, which are an external service. So what happens if they go rogue? What happens if there's a service interruption? What happens if there's a hack? What happens if they decide to raise costs because they have a perfect monopoly on the market, so you're going to pay a lot? You can have unexpected delays as well if the blockchain is congested. And here's a little extract from a scientific article that states that there's been some critical poke transactions, so these regular transactions, that was a bit delayed, and MakerDAO lost $4.5 million because of it. So that's not something you see because that's something user-facing, but it's a big problem in DeFi currently. So to illustrate this very concretely, imagine that we want to create, let's say, an arbitrage bot. A bot that automatically detects arbitrage opportunities between two decentralized exchanges and tries to buy on one and sell on the other to pocket the difference. So the way you could do it is host a server or have somebody else host your server. That server would hold a secret key. That server will also regularly observe the blockchain, see that there is an arbitrage opportunity, and send a signed transaction to execute the arbitrage opportunity. So here you can see that if the server is down, you would lose opportunities. If the server secret key is compromised, somebody can just drain your account. If the server transaction is late, you can end up executing an arbitrage opportunity that's not there anymore. So many things can go wrong there because you're outside of the blockchain. So we thought about it, and we thought about how we can solve that problem by moving everything on-chain. And the solution we found is simplified here. So the way it works is that imagine that our arbitrage bot is now a smart contract in the middle there. And the arbitrage bot registers a wake-up alarm that tells that a given function will be called within the smart contract in 5 seconds. And in 5 seconds, the blockchain itself is going to call that smart contract. So it's going to wake it up. And whenever it's woken up, the smart contract is going to register again, wake up in 5 more seconds. So every 5 seconds, the smart contract will be woken up by the blockchain itself, on-chain, deterministically. And every time it's woken up, it's going to look for arbitrage opportunities in the dexes and atomically generate a transaction to execute the arbitrage opportunity. So the full chain between detecting arbitrage opportunities and executing them is entirely atomic here. That's a very powerful thing. And the smart contract itself is on-chain. It's going to run forever as long as it can fuel its gas. So that's kind of our vision because it removes any dependency for external servers. So how does it work? Well, here is the guts of it, how it works. In a traditional blockchain, you have the left side here. So you have a mempool, which contains transactions that nodes have seen, but that are not included inside blocks yet. So the way it works is that usually a user emits a transaction, it propagates, it ends up in this pool that all nodes can see, depending on what they have seen in terms of transactions. These transactions are candidate transactions. They have not been included yet. So the block producers are selected one way or another, proof of work or proof of stake. They look into the transactions that they have seen that are not included. They pick some up. They include them in their blocks. And then when the block is executed, the transactions are executed in the order in which they appear in the block. That's the one-on-one on how blockchains work. In Massa, we have added another pool that's called the autonomous pool. It's the red one to the right. And this one is not something that's specific to every node runner. it's something that all node runners share as part of the state. So it's part of really the deterministic state. The autonomous pool is stored at the same place where the smart contracts are stored. So everybody agrees on it. So that's a very important thing. And the way it works is that at the beginning of every time slot, we have one time slot every 0.5 seconds. Every time we're gonna draw through proof of stake somebody who is responsible for creating a block. That's pretty traditional. But we are also going to tell everyone, even if there's no block, even if there's no block producer, that they also need to deterministically pick some messages in the autonomous pool there and execute them. So the algorithm that is used there is very similar to the way block producers choose which transactions to include. They basically look at the most profitable ones in terms of fees. And here's the same, but it's fully deterministic. So at every time slot, every 0.5 seconds, all the nodes in the blockchain look at the autonomous pool, see if there's any messages waiting to be executed for that target slot. And if there are, they're gonna execute them, everyone. And then in the same time slot, we're gonna look whether there's a block at that slot. And if there's one, we're gonna also execute the block. So that's kind of the idea. And the messages themselves, they don't come from the outside. They don't come from users sending transactions. They come from smart contracts executing. So for example, here you see on the top, when an autonomous message executes a smart contract, the smart contract can choose to emit a new message that ends up in the autonomous pool. Same thing when a transaction executes a smart contract, maybe the smart contract wants to decide to emit a message that also ends up in the autonomous pool. So you can imagine that this is fully deterministic, and even if there's no more blocks in the system, it can still run. The smart contracts can continue executing because everybody knows the rules deterministically on how they're gonna evolve over time. And to give you a better zoom on what an autonomous message looks like compared to a classical transaction, remember, a classical transaction, there's a tip given to the block producer to invite them, to incite them to include the transaction in their block. Here, we also have a tip system, but the tip is destroyed. It's burnt. Because it's not up to the block producers to include the autonomous messages. They will be executed whether they want it or not. So the tip is destroyed, and everybody benefits from it. Because we push the value, we push down the inflation of the network. And the rest is exactly the same as a normal transaction. You can decide on some validity conditions, you can decide to call a function. And within the validity conditions, actually, it's even more rich because you can choose stuff like, I want this message to be executed only at that time in the future, or only whenever something else happens on the blockchain. It can observe some events on the blockchain and get activated based on these events. So it's almost the same as a classical transaction, but it's more rich in terms of validity conditions. So this is cool, but it becomes cooler when you couple it to other elements. So one of the first elements we want to add is message passing. So we have signed a partnership with Hyperlane, and we are currently working with them. The goal in our roadmap is to implement message passing between Massa and other blockchains, so that Massa can be used a bit like a gelato, a bit like an automation network that will be able to where smart contracts are going to be running autonomously and can send messages to other blockchains to automate them. So Massa can become an automation center for other blockchains. So that's one of the visions we have. Another vision that Sébastien mentioned is that in the future, we want to study the implementation of an EVM on the side of Massa, which will allow people to port existing smart contracts to Massa and automate them, EVM smart contracts. That's also very powerful. So it would be the first time you would be able to fully automate on-chain existing EVM smart contracts. In the more distant future, we can imagine even adding more VMs. Like we can imagine the Solana VM if we can get a grant from them. So if you know friends at Solana and that are ready to grant us to add the SVM into Massa, we're ready to add it as well. And that way we could automate also other smart contracts. So this is like the long-term vision here. And there's also something we want to implement, something new. Because if you look closely at this system here, it works very well, but there's some edge cases where, for example, the autonomous pool can be full. Then some of the messages might be dropped because just the same as the classical pool. If somebody sends a lot of transactions at some point, the mempool is a finite size. Nodes have not infinite memory. So there are some constraints here. So in some cases where there's a lot of load on the network, the autonomous pool is going to prioritize the transactions with higher fees, so that it might cause delays on the execution of messages that have lower fees. So to solve that, we are currently studying another complementary type of autonomous smart contracts, where it works a bit differently. We have these time slots still, but the way it works is that the smart contract can ask for a quote, a bit like reserving a plane. There's a plane departing every day, and you can reserve planes in advance. So the smart contract, we can ask for a quote to ask how much it's going to cost to execute that much gas at that time in the future. And it's going to get a quote that's automatically deterministically generated through a future predictions market. And then the smart contract can accept the quote or refuse it. So for example, in slots where there's already a lot of gas reserved, the quote is going to be more expensive. And for slots that are empty, it's going to be cheaper. So the smart contract can decide whether it accepts the quote. Then the smart contract reserves some execution time at a given future slot, and it's going to be guaranteed to be executed there. Or they can refuse the quote and say, okay, I'm going to look around, see if there's any slots, any other plane that's less full, where it's going to be cheaper for me to reserve it, and reserve it there. So the smart contracts have full autonomy on future call reservation. And once it's reserved, it's guaranteed to be executed. So this is a complementary type of autonomous smart contracts that is still under research, and we're going to work on implementing it next. But for now, we have already this type fully working on the mainnet right now. You can already play with it, and feel free to try. So that was kind of the guts of the system, so feel free if you have any questions. Yes, I think you were first.
So verifying those validity conditions, you said you trigger by certain events. Is that arbitrary sort of contract logic that you can use?
Actually, because of the fact that these triggers are checked every time there's a change on the ledger, you can't really afford having arbitrary code there. So we have a list of possible conditions right now that are a range of slots, a range of time slots in which the autonomous message can be executed. It cannot be executed before, it cannot be executed after it expires, and all the coins are reimbursed. And there's some conditions that it can have. For example, it can check whenever it can get active, so it's allowed to be executed only when there has been a change on a given smart contract, for example. So we have conditions on changes on other smart contracts. You can define exactly the address of the smart contract and optionally the entry in the data store of the smart contract that's going to trigger the activation of the autonomous smart contract. That's already on the mainnet, actually.
So the way that a limit order works right now is anytime the pool price changes effectively, there is a execution of that autonomous transaction, and so you're spending gas every time to evaluate price.
Yes, so the way you can imagine it is that you have these price evolutions, whether they're fed internally by a DEX or externally by an oracle. And you have all these smart contracts that are ready to observe this change. They have this condition, so whenever there's this change that happens, they're going to be enabled, which doesn't mean that they're going to be executed right away, but from now on, they're allowed to be executed. And they're going to be executed as soon as there's space to execute them. So that's the current implementation. Yeah. Yes?
I was just going to say that I can imagine a lot of people asking questions about like gas.
Yes.
How it works, since it's but it seems like the deterministic nature of like the slots just like automatically executing. It means that it reduces gas in that way because it's just like automatically. Well, the slots already executing the smart contracts, right?
Yeah. So basically, the tricky part is that these slots, they're very discrete time slots in time. So every 0.5 seconds, there's one. So you need to make sure that the execution time you need for each one of them does not exceed 0.4, for example. Because if it takes longer to execute a slot than 0.5 seconds, your blockchain is going to be later and later on the execution. Basically, slots are going to appear faster than you can execute them. So that's the fundamental constraint you have. And indeed, you need to share this execution time that's reasonably short between the block at the bottom and the autonomous smart contracts at the top. So there's a finite gas you have reserved for the autonomous smart contracts and a finite gas for the block. For the blocks, I think it's 1/5 of the time, and for the autonomous smart contracts, it's 4/5, and for autonomous smart contracts, it's 1/5 of the total slot time available for execution. So that's the current way it works, because currently it's this space here is reserved for autonomous executions. And in the future, when we have this, what we're gonna do is that we're gonna move this slightly. So this will be reserved, this fixed amount of gas will be reserved only for the reserved guarantees of autonomous smart contracts. And these ones, the normal ones, will be moved after. So all the remaining gas that's not being used in the slot will be dedicated to autonomous smart contracts. So that should help things a lot. But this is the current implementation. Well, the block always has the guarantee that if there is a block, it's going to have all its gas available to execute all its transactions. So we're never going to prioritize stuff over blocks. Blocks will always be there and have their reserve of gas. As for the guaranteed autonomous smart contracts, they're also going to be guaranteed to have at least 1 billion of gas. So it's fully deterministic. As for the current smart contracts, they're going to be moved at the end with all the remaining gas that's not been used by either of these executions. Yes?
Connects with Dusa actually, because Dusa has, you can create strategies, trading strategies based on a smart contract, right? And I have a company which is building bots, like trading strategies for centralized exchanges. But the biggest problem we face usually is when it comes to a strategy designer, they don't want their strategy to be seen by anybody else. So how do you make sure you protect that strategy in a smart contract? How do you make sure it's not seen by anybody else?
Well, that's a tricky one because the naive thing to say is, oh, you compile it, so it's compiled code, so decompiling it, it's going to be hard, and it's going to be hard to see it. A bit like when you buy a software program that runs locally, they trust you in a way that you're not going to reverse engineer it. That's the naive way of saying it. But in the future, we can imagine smarter ways. For example, one that comes to mind would be some kind of MPC between different nodes of the network. They can imagine working together on defining some particular secret key that's going to be used to execute something. But for now, we don't have that. So for now, it's a public blockchain. We don't have this privacy layer. We are working closely with, actually with Starknet and Polygon. So we are starting to have a pretty strong expertise in ZKs. And that might be the next steps we're going to think about in Massa. But the issue we have is that we are a very high throughput blockchain. We process thousands of transactions per second. And adding the ZKs to the mix, unfortunately, nowadays, despite many claims, ZK blockchains are very slow. It's going to improve over time. That's what we expect, but for now, it's very slow. And for now, that's not something we can add right away in the blockchain. So for now, the trading strategies will be, at best, obfuscated, but you will not be able to hide fully for now until we add either some kind of MPC or some kind of ZKs. Yeah. Yes?
Massa becomes more and more popular, and the load on the network increases. Wouldn't it be kind of too expensive to execute the stuff on-chain rather than traditionally off-chain?
Well, we have a lot of gas still available. We can process thousands of transactions per second. So far so good. And this is allowed by the fact that we have this WASM virtual machine. And the way it works is that you program your smart contracts in whatever language you want. You compile them towards WebAssembly, and this WebAssembly code itself is compiled on the blockchain when it's uploaded using Cameleonz with optimizations. It's compiled in a way that its execution is deterministic, but it's optimized for the local machine of the node runner. So that's what's stored in cache on the local machine. And it's way more powerful than any interpreted language. Like it would be way more efficient than an EVM, for example. That's why it's also harder for us to add an EVM. That's why it's a study still. Because thanks to this, we achieve very high gas because we're executing native code. It's not an interpreter. But it also means that there's a trade-off. When you upload a smart contract on Massa, it costs you a lot of gas because there's a Cameleonz compiler running there. So that's how we achieved way higher throughput. So we have a lot of gas available still. So the problem you're mentioning is in the further future when we achieve such a success that all the gas is used. And there we have some ideas to scale it using parallelization. We can discuss it. There's some ideas to parallelize things, but there's still some pitfalls that we need to fix with this. For example, you can imagine executing smart contracts in parallel and tracking their access lists, see which resources they access. And if you see some collision in access lists, you re-execute the ones that are that entered the collision and that were supposed to come after. And when you re-execute them, you end up actually going faster because we're reusing most of the cache data from the previous execution. But there's a tax. You can create and forge transactions that actually change their access lists every time they're re-executed. So you screw up any kind of caching and you can literally break the blockchain using that. And that's an issue Monad have. I sent them a message actually to warn them about it. They're looking into it, but that's not something we want to throw there before we're sure of the security. Yes?
What language are the smart contracts written in?
So currently it's a WebAssembly virtual machine. So in practice, you could compile any kind of language that compiles towards WebAssembly, Rust, C, C++, anything. But we decided to build our first SDK, the one we have currently, in a subset of TypeScript called AssemblyScript, because it compiles natively to WebAssembly, very high performance, and it's very familiar to any full-stack developer because they know TypeScript. So that's how we have had amazing teams like Dusa here, who during the time of a hackathon, without knowing anything specific about Massa, were able to deploy a full project because if you're an experienced full-stack developer, you can build on Massa. That's the cool thing. But it has pitfalls as well, because if you have existing smart contract developers that are used to Solidity, it's hard to migrate. So the foundation is helping them, funding their migration to rewrite their smart contracts, do some audits, but it's suboptimal. That's why we are researching also adding an EVM on the side. Yeah. Yes? Okay, so this part is decided by block producers. They choose what they put inside. This is not in the state. This is literally just what they have seen. But this is fully deterministic. Nobody decides what's there. It's an algorithm that prioritizes messages based on the ratio between the gas they use and how much fee they have burnt. It's kind of the same algorithm as here. How much resources you use versus how much tip you bring to the block producer. It's the same way they prioritize transactions here.
Does that mean no matter what, you end up with the highest, like using up all of your gas within that transaction? Because if you have two transactions and say, okay, this is the maximum I'm willing to pay for this fee, they're automatically bidding against each other. There's no way to get. You're not setting a max fee. You're actually setting a gas price.
You're setting max gas. The maximum amount of computing time that is allowed to run for your system. That's a way for, basically, we use this here as well. In our transactions, you don't have a gas price. You set an actual max gas. Why? Because we want node runners to just be able to look at the transaction without simulating its execution and be able to include it in a block very quickly without having to simulate any kind of execution. They just look at the fee, they make sure that you can pay it, and then from there they have guaranteed that they will win the fee. They know exactly how much resource in terms of gas they have left in the block. So there's two resources in the block production. It's block space and block gas. So there's a finite number of gas allowed inside the block. So the block producers need to kind of fit transactions depending on this. And there's a finite amount of space in the block as well. So the size of the transaction and the amount of gas it's advertising to use at most are the two factors that block producers look at, and they relate them to how much fee they get. So they kind of try to pack as many transactions to win as many reward as they can, while minimizing resource usage. Because if you have even if you have a higher fee from a transaction, but it uses all your gas in your block, then you cannot fit other transactions. So it's kind of the idea. And on the deterministic pool here, it's the same, but the only condition is gas. There's no size limit. I mean, it's limited to 10 megabytes per object. But so the autonomous pool here contains messages prioritized by the ratio between the fee that's been burnt to produce it and the amount of gas that it's going to take at most, the max gas. And the algorithm is fully deterministic and fully automatic here. But it looks like the algorithm, the node runner is here.
Okay, so you know how many executions you'll be able to have with a single autonomous transaction?
Yeah, you know exactly the amount of gas you have available. Yeah. Huh? Yes, but at that point we will have this complementary type of transactions, autonomous transactions that will guarantee 100% not only the gas availability, but also the exact time you will be 100% sure that at that exact time it will be executed, and it cannot fail. That's the idea. Okay, no more questions. Thank you everyone for your attention, and enjoy the meal here. Enjoy some more networking, and we can chit chat if you have any questions. Thank you.